Hey everyone, hope you're doing well. Thanks for watching today's video. We're going to talk about the exterior angles in polygons. So again, part of this rule, just like the interior angles rule, only applies to regular polygons. So quick refresher of regular. Regular means all the angles and all the sides have the same measure. So regular squares, equilateral triangles. Then irregular just means that that's not true. So at least one of the angles or one of the sides has a different measure than the rest. And so that's an irregular versus a regular. So let's get into the exterior angle rule. So what it says is that for polygons, the total sum of their exterior angles is always 360 degrees. So pretty simple rule here. And so that means for the measure of each exterior angle of a regular polygon, it must just be 360 divided by n, because again, it's kind of like the sum of the total angles outside, which has to be 360, divided by the number of angles, which is n, the number of sides. That must be the measure of every side. So a hard thing for me personally was always, well, what does it mean by exterior angle? Because it's kind of hard to imagine, because I think about my interior angle is obviously 90 here. That's easy to see. But what do you mean exterior? So the best way for me to think about it is to extend any of the lines. So just take this and extend it. That's your exterior angle. So maybe you wanted to take this one. You're going to get the same answer. That's your exterior angle. This one, that's your exterior angle. This one, that's your exterior angle. So that's kind of how you imagine what these exterior angles are. It's kind of if the lines just continued out forever, what would it look like? So let's figure out what are these? Why are these 90 degrees? Well, let's plug in our formula here, 360 divided by n, because this is a regular polygon. 360 divided by 4, that gives us 90 degrees. And that's why all our exterior angles in a square are 90 degrees. Now let's think about it again with this regular. We're assuming it's regular, so all the side lengths are the same and all the angle measurements are the same. So again, let's imagine kind of extending this here. So that's an exterior angle, this is an exterior angle, and this is an exterior angle. And what we say here is if all the measures of the exterior angles are the same, well, they're all congruent. So I can do my little dashes here to show congruence. And it's going to be 360 divided by n. Well, n in this case is 3. There's 3 sides. So 120 degrees is the measure of all of these angles right here. And that makes sense. They look obtuse. And another way to think about it is for an equilateral triangle, you know all the measures are 60. And then you get this straight line angle. It must be 120 plus 60 equals 180. Just another way to think about it. So, and remember, just for interior angles, the interior angle rule here is 180 times n minus 2. And so each angle in a regular polygon has to be 180 n minus 2 divided by n. And the new exterior angle rule actually gives us another way to calculate regular interior angles by doing 180 minus the 360 divided by n. This is an important concept. So what it's saying is that if you figure out the exterior angle, so if this, as you know, is the formula that we have right here, 360 divided by n, the measure of each regular exterior angle. What I'm saying here is that I can take 180 minus that to get the interior angle. Let me show you why that's true. We kind of talked about that with our square, but I'll just draw another one really quick. What I'm saying is that, okay, so let's extend the line. As you know that this is a straight angle. This has measurement of 180 degrees. That's where this comes from. Then we're saying, well, the exterior angle is 360 divided by n. That's this. So I have that angle. I'm trying to figure out this one. Well, I can do the entire angle, which is this 180, and subtract this outside part, and I'm going to be left with the inside part right there. So that's how this rule comes, and hopefully that makes sense. We'll get into it a little bit more with the examples in a second. So hopefully now you're kind of understanding what it means by exterior angles. I know that was a big hurdle for me when I was going through this course. So what is the sum of the exterior angles in a 50gon? Okay, so we got a lot of sides here, but again, this is just really plugging in our formula. It's just going to be 360 divided by 50. Let's try to simplify that a little bit. First, I see both can be divided by 2, and let me show you where I got this from. This is the 360 divided by n formula, which becomes 360 divided by 50, and I'll do the equal sign because now we're simplifying. Let's divide everything by 2. We get 180 divided by 25. We can then divide everything by 5. What will we get? We'll get 38, right? No, not 38. 20. Was 38 right? 36. 36, yep. 36 divided by 5. And can that simplify further? I don't think so. I think that's going to be as far as we go. So we'll get 36 divided by 5. So now let's go on to the next one. So what must the measure of every exterior angle be in a regular pentagon? So pentagon, 5 sides. So if I'm figuring out what must the measure of every exterior angle in a regular pentagon be, must just be 360 divided by 5, which equals 72 degrees. So that's what the measure of every angle in a regular pentagon will be, every exterior angle, I should say. What if it said every interior angle? Well, I would do 180. That's that new formula, 180 minus 72 degrees. And I would get 180 degrees. And now let's make sure that works with our old formula. Remember the sum of interior angles. So now I'm using my interior angles formula to figure out, well, what is the measure of all the interior angles of a regular pentagon? That's when you take the length of the measure of the total interior angles, which is 180, times n minus 2, which is 5 minus 2. And I divide by n, the number of sides, which is 5. So then 180 times 3 is going to be 540. Divide by 5, and that is 108 degrees. So not 1080, 108 degrees. So let me write out just so in case anyone sees it. These are the interior angle measurements. And this is the exterior angle measurement here. So those are just two ways to find the interior angle measurements that we talked about. And now let's get into this last example, numerical example. This one can be tough. So pause the video, see if you can figure it out. We're trying to find x, and we're given an outside measure, and we're given an inside measure. So a lot of things are going on here. I know that the outside measures have to add up to 360. So exterior angles, I know they must add to 360. And I'm given one of them. So I'm given 4x minus 20. But there's a reason that these are congruent. See these little dashes here? That means that those are congruent. If the angles inside are congruent, well, that must mean these angles outside are congruent. So this one's also going to have to be 4x minus 20. So that helps, but I still don't know the last one because see how there's no dash on this angle? So I don't know if it's congruent, but I can draw this out a little bit. Let's draw what this is going to look like. This is the angle I'm looking for, this one. Somehow I have to figure that one out, but so far I have 360 equals 2 times 4x minus 20, right? Because I have two of those angles plus this last angle I'm trying to figure out. Well, we actually have enough information to figure out a way to write that angle because I know that this angle here, this one, the one that is 2x minus 4 plus this new angle that we're trying to find, they have to add up to 180. So what I can write the new one as is one, let's say, yeah, 180 minus 2x minus 4 has to equal that new angle. So that's what this equals right here. Because of the straight angle here, I can subtract that part of it, the 2x minus 4 part, and that's going to give me what I want, that new side. So now I'm going to add that to here, 180 minus, and be careful with parentheses here. It's really important to put the whole thing in parentheses, the 2x minus 4. This is a challenging problem, so it's okay if you're not getting it right away. And then now you just solve. Now it's just an algebra problem. So the hardest part is setting it up. Shouldn't be too bad here. So 360 equals, distribute that to 8x minus 160 plus 180, or not 160, I don't know where I got that. 2 times 20, net minus 40. I really don't know where I got that. Plus 180 minus 2x. So now I'm distributing this negative. Be careful here because you got to distribute it here, and that makes it a positive. So plus 4. Okay. So now I'm going to combine like terms. 360 equals 8x minus 2x is 6x. Minus 40 plus 180 plus 4. So minus 40 plus 180 is going to be 140 plus 4, 144. So 6x plus 144 equals 360. Subtract 144 from both sides. I'm left with 216 equals 6x. And then divide both sides by 6. I get x equals 36. And that is my answer to the problem. And the reason why is that 180 minus 2x minus 4, that's the key part, has to be that last exterior angle. And another reason this was difficult is because you had to recognize that if the interior angles are congruent, these two here, well, their exterior angles have to be the same as well. So hopefully that was able to make sense. If you're able to do the last one, you have a good grasp on interior and exterior angles, I would say. And so a lot of this stuff is just memorizing these formulas. This one, really just all of them, and the new one there, 360 divided by n. So hopefully this makes sense. Hopefully you have a better understanding of what exterior angles are now. and let me know if you have any questions. Thanks for watching.